I just want to prepare you. We're going to do some math today. So that's why I saved this to the end on this material. That's not too bad. I think you'll go along with it. So what we're doing is we're looking at situations where firms have a small number of firms that are acting strategically with each other, right? So it's oligopoly is what we're looking in at, and how they might compete with each other or attempt to work with each other. And so when they work together, what did we do last time? What's going on when two firms try to work together? A cartel. So they're acting like a monopoly, right? So that's all we did. The first thing we set up was a monopoly. And what did we find out on this problem for part A? What did we find out? How much was each firm going to produce? So quantity of 4 was the total amount. I kind of felt like maybe we did not have that completely down. Let's see, I'm not sure how. It seems like, I'm going to bring this forward a little bit. Okay. So draw this picture if you didn't from last time. I think it's just kind of helpful. We had the inverse demand, the market demand for chlorine was 32 and minus a 2 slope. So we had a demand that looked like that. If we treated them like a monopoly, each one had a cost of 16, half of 32. So marginal costs look like that. They're acting together like a monopoly. So this is just our monopoly model from before. Marginal revenue equals marginal cost at 4. Charge the highest price people are willing and able to pay, which we came up with what, 24? All right. So 4 was the market provision. So how much is each firm going to produce? 2. So that was the difference. Kind of I wasn't sure where we left off last time. I felt like that wasn't totally clear. So, so profits for each firm then, they're going to split the market, each do quantity equal to 2. And I just want to introduce you, we're going to play more with this. Remember that big Q, the market quantity acting like a monopoly, is the sum of the 2 little guys here, what were their names? Biobase and Squeaky Clean. So QS plus QB equals 2 plus 2 equals 4. So we're just going to split the market evenly, divvy it up between us, right? And so then we had profits of $24 per ton, which was our $24 minus our $16 cost times our quantity of 2 gave us our $16 profit for each company. So profit for Squeaky Clean was equal to profit for Biobase. They're both making the same amount of money. All right, so now, does Squeaky Clean have an incentive to cheat?
Yes.
So yes, why?
Because the selling price is greater than the marginal.
Good. Selling price is greater than the marginal cost. But now, let's see what the impact, let's play it all the way through is where we left off with. Because when they cheat, what happens to price? It goes down. So we got to factor that into the equation. So do that now. Start working on that. So part B was having the price go down. So yes, but price falls, so check profit to make sure that they really do have an incentive to cheat. Because if the price effect overwhelmed the quantity effect, that's what we learned with elasticities, it might not make sense to do it. So we're going to double check it.
We're just doing one more unit
Yeah, one more unit.
Per firm or just one altogether?
So one altogether. So one firm is assuming that the other firm's not going to do it, right? So we're thinking, does each, and it's going to be the same answer for both. Turns out they both will have incentive to cheat if one does. But if they cheat, what does the price fall to? How much? 22, right? So imagine the fifth unit, plug that into your inverse demand function, price is going to fall to 22. So that's the new number that you need to factor in. And of course, there's only one price out there, so it falls not only for that extra unit, but for the previous units. So same thing we learned before. So what is the new profit for squeaky clean? Yeah, for the cheater. 18. All right, so we got 22 minus our costs are still the same, but now we're producing 3 units instead of 2. Remember, this extra unit is the cheater's unit. So now we're producing 3, right? 6 times 3 equals $18.
And the other one's just gonna be 6 times 2.
Yes.
Where's the 3 coming from?
The 3 is the extra unit made by Squeaky Clean. They were making 2. Remember, we started the problem off in part A, is that QS and QB is all equal to each other. They're going to split the market, and each one's going to produce 2 of the total of 4. But in order to get that extra unit, we have to use the market inverse demand curve to figure out what the price is going to fall to with the extra unit. Okay?
The profit increases to 18.
Yep. So Squeaky Clean's profit increases to 18. All right. So does Squeaky Clean's decision to cheat affect bio-based profit? Part C. So part C, how does it, yeah, it's going to affect it. So what is bio-based profit? 12. So if we're all tracking here, again, they stay at 2 units, right? So we're kind of saying, okay, price falls to 22 because they cheated, one guy cheated. They still have 16 worth of cost. They're still producing 2. 2 times 6 is 12. All right, everybody with that so far? Now, D. Suppose that both firms agree to produce 1 more ton, because that would be fair. So we both, since we're both going to cheat, what if we both go up by 1? How much profit will each firm earn? Does Squeaky Clean now have incentive to cheat? So if each firm produces an extra unit, we got to recalculate the new market price with 6 units being produced. I don't have this drawn to scale very good. So we need to plug that back into the market demand. So D at big Q equal to 6.
Why did you go to 6 and not just 5? But if they're already producing, like, I would, then the way I would read it, I would go back to 4 and then say each firm are producing 5. Am I wrong with that? Like,
Because each firm's going to produce 3 units is what. So if they split the market
okay.
at 3,
Gotcha.
so they are both allowed to cheat. Hey, you're going to cheat, I'm going to cheat. Why don't we just cheat together? And so that's kind of the scenario that we're drawing up. So at Q equal to 6, we've got Squeaky Clean and Biobase splitting it at 3 apiece is what the question's asking. How much profit will each firm earn? So we need to determine the new market price, 32 minus what is it, 2Q? Yeah, 2 times 6 now. And what's the new price? 20. And what is profit for Squeaky Clean? 20 20 minus 16 times 3. 4 times 3 equals $12. And it'll be the same for the other one, right? Because we're both doing 3 and we got things kind of equal in this particular case. So the question just asked for squeaky cleans, but you're right, they're both. Now, reevaluate. Does squeaky clean have an incentive to cheat? Max.
Where did you get the 32 minus 2 times 6 for the key? That's your price.
This is the inverse market demand curve. This demand curve right here is P equals 32 minus 2Q.
So you already figured it.
Yeah, that's the market demand curve, which was given to us in the problem.
Okay, yeah.
Okay. So, does squeaky clean now have incentive to cheat? No. Why? All right. Profit goes down to 8. So profit actually goes down now on the incremental unit. So the answer is no. We got to go plug in a 7 into here, right? So again, one firm cheating, assuming the other one's not going to cheat. That's what true cheating is, right? We don't have a collusive agreement. So we got 2 times 7. Market price then would be equal to 32 minus 2 times 7, which is 14, giving us a price of $18. So price would fall after the cheating, price would fall. And squeaky clean's profit would be 18 minus 16 times now the number of units, which would be cheating, the cheating number, which would be 4. 4 times 2 equals 8. So there's no incentive to cheat anymore because by cheating, profits fall, right? So we're just, again, kind of carefully looking at the incentive to cheat, whether it exists or not, because their individual behavior holding the other one's constant, which is kind of the Nash way of doing it, remember, does either firm want to change their answer, taking as given what the other one's done? That was the Nash equilibrium that we'll study more in the upcoming chapter 2. Neither firm has incentive to cheat. So this would be an equilibrium at this cartel collusive agreement. They're still holding back on some profits, or on quantity.
Which one's the equilibrium?
At this collusive agreement of both splitting the market at 3
I could be splitting market.
is stable. We started at 4. That wasn't stable. Why was it not stable? Because they both had incentive to cheat. So it's not a Nash equilibrium. If one person wants to change their answer, taking as given what the other one's done, it's not stable. It's not a Nash equilibrium. So having that incentive to cheat, from an economist standpoint, says that that's probably not going to hold up in the long run.
I guess my question is like,
Without other threats of violence, maybe, or something.
when they produce 4, they're making the most profit. So if they cheat, the other one's going to cheat, which means their profit's going to go down. So why wouldn't they both just stay at 4?
That's kind of the heart of the argument, is why we find collusive arrangements falling apart. So yes, they both know it's better, which is similar to what we saw in the prisoner's dilemma. You weren't here, but we reviewed the prisoner's dilemma. Oh, you saw it. Okay. So both firms would like to work together, but the incentive to cheat is strong, and so it's not stable over time.
They're thinking that the other one's going to do they just take that step first?
Our underlying premise is that self-interest drives the world, ultimately in the long run. And for better or for worse, by the way, that's contested sometimes in situations. But from a kind of a mathematical standpoint, as well as a rational standpoint, if we go with the rational actor paradigm, is what it's called, where self-interest rules the world, that's not a stable outcome. And you might need other things, like, I'm going to kill your family if you cheat on this agreement. What does that do? It just raises the cost and makes it stable, right? Changes the payoffs so that it's not just this extra amount of profit that you're going to get by cheating, but it's also going to cost you your left arm.
So So you're saying that,
or harm to your family. You see what I'm saying? And that's just bringing kind of some non-monetary costs to the picture that now all of a sudden make the collusive agreement work. Okay.
so what you're saying is that a regular monopoly without a cartel would produce 4, sell it for 20.
Yep.
But since the cartel, with each of them having the incentive to cheat, they each cheat once, but the incentive to keep cheating goes away because their profit's going to decrease even further, correct?
Yeah, and we're kind of playing more into the story than what we maybe have. But given these circumstances,
So I guess
under the assumptions of the model, remember it's still an economic model, which we can make more complex to tell maybe a more interesting story. But given these circumstances, we're just saying that that equilibrium's not stable.
Well, I guess I'm just confused at why they would drop down to profit being 12 when they could have just stayed at profit being 16 at the very beginning of 4.
Well, they don't think that they're gonna drop down to 4. They, one tries to get higher, but ultimately in the long run, they drop down to 4.
Yeah, the one person cheating left them better off in the first example.
Well, left the cheater better off.
Left the cheater better off.
So the other guy-
And that cheater's assuming that the other guy's not going to change, or if I can sneak it by him, if this is a one-shot game, then and screw them. I don't really care about them. It's just it turns out to be good if we work together. But I've got this incentive to cheat, and so it falls apart.
Okay.
Max, do you have something else?
I was just gonna say, so, yeah, they benefit at the expense of the other, correct? Until we get to Q equals 6, where the incentive to cheat is no longer
Right.
there, which is Nash equilibrium.
Right. So now it's stable. Yep. That incentive to cheat's
Because
gone.
they each already cheat. Right.
Possibly, yeah. Maybe you're kind of telling more of the story
I
again,
guess- I
but
guess-
that would be possibly it. One cheated, the other cheated. They're like, oh man, okay, let's both cheat together then and make another agreement. Does this agreement have a chance of holding? The answer is yes, it does, because
now it's-
neither firm has incentive to cheat anymore. So it's like, yeah, okay, that's kind of a no-brainer.
So with this,
Why would I hurt myself, right? Because the individual action, taking individual action now harms their self-interest, and so they're not going to do it. And so it's stable.
so every single time that there's a cartel, this is going to happen. There's never going to be where they just stay with
This is still a cartel, so that's why we brought this up. They're still working together, but it's stable. It's a stable cartel.
But I mean,
So we're digging a little bit deeper.
they're never going to stay at that Q equals 4, Q equals 20.
That's the prediction. Without entering in, if you cheat on this agreement, I'm going to cut off your left arm.
Okay.
Then all of a sudden we've changed the payoff matrix, right? Is the way to think about it. If we add a cut off arm in addition to the monetary benefits, then we've changed the dynamic of the game.
So the Nash equilibrium is Q equals 6, P equals 20.
Yep. That would be the outcomes, yes.
And that's where they're both better off. It's stable.
Yep.
Could there be like a legally binding contract for this?
Yeah, that would be another way to do it. Yeah, if it wasn't so, well, in a different set of circumstances, yes, there could be a legally binding contract where I'm going to sue you, and so now you've got the chance of a lawsuit that might be enough to change the payoff matrix again. Good point. If it's something legal.
Right.
Which two firms acting as one as a monopoly is not legal in the United States. So they're already in the illegal world, let alone if we're getting to the drug dealing story. But if because monopolies aren't allowed and it's anti-competitive behavior, we have laws on the books that say you can't do that.
So it's a different country.
Different country, different set of circumstances though. There might be some arrangements where we might be able to work as a joint venture on a project or something like that, or something where it's not illegal, that a contract could be enforceable. All right, 11.2. We're going to look at a little bit different setup called the Corno duopoly. So it's a version, this is just kind of a special version of an oligopoly. So instead of a monopoly, monorail, if you take the monorail, how many rails are there? One monopoly, one seller, mono. So now we've got duopoly, two firms competing with each other. So we've got Oil Pro and Grease Tech are the only two firms who provide oil changes in a local market. Maybe it's Ottawa even, in a Corno duopoly. The oil changes performed by the two firms are identical, and consumers don't care about which firm they purchase an oil change from. The market inverse demand curve for the oil changes is P equals 100 minus 2Q, where Q is the total number of oil changes in thousands, and produced by the two firms, QO and QG. So the market quantity is determined by the two companies, QO and QG. So there's a couple formulas we'll start with. Oil Pro has a marginal cost of $12. Marginal cost for Oil Pro is 12. And Grease Tech has a higher marginal cost. So now we're going to change the marginal cost around for each company. So Grease Pro is $20. Assume that neither firm has any fixed costs. Determine each firm's reaction curve and graph it. So how is one firm going to react to another firm? All right, so this is where we get a little bit different than what we've worked on before. All right, so first step we want to do is kind of transform the market inverse demand curve using this. So I'm going to substitute this relationship for the individual behaviors into there. So let's call this equation 1, equation 2, equation 3, and equation 4. So our first step is to sub number 2 into number 1. Which gives us price is equal to 100 minus 2 times Q0 plus, not Q0, Q oil, the quantity for Oil Pro, plus the quantity for Grease Tech, which equals 100 minus 2Q0 minus 2QG. Now, we're not allowing any collusion. Each firm is looking out for their own self-interest, but there's only 2 firms in town. So the next thing I want to look at is the marginal revenue. Ultimately, we're going to look for marginal revenue equal to marginal cost, but we're going to factor in the other firm's quantity into our decision. That's why we call it a reaction function. I'm going to react differently depending on what you make. If you make 10, I'm going to make this much. If you make 20, I'm going to make this much, right? Well, we can solve for that function ahead of time by solving for the other guy's quantity is kind of where we're going. So how am I going to react all by myself? So the marginal revenue for Oil Pro, holding constant the amount that Grease Pro is going to make. So I said, what if Grease Pro makes 10? How much would I make? Now watch how does this thing change? If I all of a sudden have a hunch that Grease Pro is going to make 10 units, offer 10 oil changes, how does that transform this function? 80, right? The intercept falls to 80. This turns into a number all of a sudden, right? So then I've got 10 times 20, or times 2 is 20. 100 minus 20 is 80. This transforms into 80 minus 2QO. I'm Oil Pro, so now I could figure out my marginal revenue function by doing the same old trick we did before. The marginal revenue is twice the slope, right? So we could do that part of it. 2 times 2 is 4. What if Grease Pro did 20 units? How does this transform itself? Drops to 60. 2 times 20 is 40. 100 minus 40 is 60. This equation all of a sudden becomes 60 minus 2Q. So instead of doing the infinite number of scenarios, I only did 2 out of infinity, right? Let's just leave it at QG and come back and do that. What does the marginal revenue function look like? It's 100 minus, now this is marginal, 2 times.
Is this step 2, by chance?
I'm not really into steps yet, but I'll just kind of flow it all together here. So the marginal revenue for oil function, the marginal revenue function, what's our trick that we do to the demand function? Times it by 2, times the slope by 2. The slope for the demand function is -2, so that's why I wasn't sure if you were saying the right answer or not, Katie. It's 2 times 2.
Would one of them stay at 2? Both wouldn't jump up and
That's right, one stays at 2 because it's this could be 10, this could be 20, this could be something. So we're not going to touch that.
Okay, the Q's are
So it's minus
4Q.
4Q minus 2QG. You got it.
Then it's the opposite for.
And now if we collapse, we can do that same scenario just to make sure you guys are all solid with this. If these guys did 10 units, 10 times 2 is 20, 100 minus 20 equals 80. We're right back to the same answer we had before, running that scenario. Max.
So is grease text the opposite? Grease text marginal.
Okay, I'm going to do that next. So yes. So the marginal revenue for Grease Tech then, if we put on our Grease Tech hat, if we had I should have little shop caps in here that I can switch between Grease Tech and Oil Pro. So now I'm Grease Tech and I'm thinking the same thing. And so it's going to be 100 minus 4QG. So I'm going to leave them in order here. So this one stays the same. Their marginal revenue is 4QG, right? Okay. Now how does a firm maximize profits? Marginal revenue equals marginal cost. You got it. We've got their marginal cost up here for each company, which is different, by the way. Now substitute that in and solve for their optimal quantity. So now we're going to sub. I'm going to put 3. I shouldn't say the word sub. Let's put set equal to. Set 3 equal to, and I need some more equations here. Let's call this equation, actually I need this one to be a 5, this one to be a 6, this one to be a 7. So to solve for Oil Pro's optimal quantity, we're going to set 3 equal to 6. To solve for the optimal quantity for Oil Pro, marginal revenue equal marginal cost. So we get 12 equals 100 minus 4QO minus 2QG. Yep, we're still going to include the other guy's thing. And you'll see what happens when we solve for this now. Now we've just got QO and QG. We're going to solve for QO is the next step. So you can do it however you... 88 minus 2QG. QO equals 22 minus a half QG. Now let's call this equation 8. This is Oil Pro's reaction function. This is O's reaction function. We call it that because it shows how Oil Pro is going to react to different quantities that Grease Pro does. So equation 8 is oil pro's reaction function. All right, now we've got that down. We can solve for G's reaction function. Doing the same exercise. No.
Wouldn't it be QG equals 23 minus 25 QO?
No. Look, start to process it, and you'll
Oh,
see.
because of the.
Yep. Marginal cost is different, so you're going to get a different answer. So set 4 equal to 7 to solve for QG star. I'm just going to write the answer. You guys can check. It's close to the same answer, but the intercept's a little bit different.
This is all part A, huh?
This is all part A, long part A. The other parts are a little bit shorter. You running out of paper? Yeah, you might have to add on. Sorry. I might have to mentally try to include another sheet in there. All right, so then graph it out. And you're going to be measuring grease probes quantities on.
We have 3 graphs.
No, just one. So put grease pro's quantity on the vertical axis, oil pro on the horizontal. Notice that we have slope-intercept form of a line. One of them's easier to graph right away than the other. Which one's that? The grease pro, right? Because why? The intercept's already, so the function's already lined up the way we need it lined up. Y equals mx plus b. The vertical intercept variable's already on the left-hand side. So that one's a little bit easier to graph right away.
So marginal cost is the very top of it.
What's that?
So marginal cost is at the y-intercept.
No, we're measuring quantity of grease pros. So this is a reaction function, and that's why I want to just graph grease pros first. So if we graph this down minus 1/2 over Q, this would bring us out to 40, would be the intercept. And let's think about this function. If oil pro produces 10 units, how many am I going to produce? 10 times 1/2 is 5. 20 minus 5 is 15, right? So it's how I'm reacting to the other person's quantity. Kind of quickly solved with this quantity function. So that's the reaction function for them. So next we're going to graph the other guy's reaction function, because we're going to start to play that game of, well, if he does this, I'll do this. But the other guy's thinking the same thing. If he does this, I'll do this. So where do we end up is what we're solving for, which I'm probably jumping the gun now. Yeah, I'm jumping to kind of part B on how we solve this. But let's graph it out first. What's the intercept now for oil pro? 44, right? So you need to solve this for QG in order to graph it. So if we bring that over, since it's 1/2, we're going to multiply times 2. So the intercept's going to be 44. And That's going to leave us down to, if I was drawing this real pretty, a little bit further this way. So oil pros reaction function, we want to graph in this space, but this is on the horizontal axis. So we need to convert that. So,
Oh, it's just the inverse of that.
right, in order to graph O's function in this space, this two-dimensional space, then you need to take the function and manipulate it back around. So need to solve equation 8 for QG to put it in slope-intercept form. You could plug and chug, by the way, too, is another way you could graph it, right? So you could plug and chug and say, well, suppose that Grease Pro produces nothing, and then we get 0, it equals 22. That was pretty easy, right? So we could plug and chug our way to it, too. All right. So now, the question of the day.
24, 22 is O, and then the 2040 is G.
Yes.
Okay.
Yep. So this is G's function,
So it's just 44 minus what, 1 QG?
and this is O's function, reaction function.
Versus manual.
44 minus 2.
Minus 2Q.
Yeah, minus 2Q.
2Q.
So QG equals 44 minus 2QO. But again, Max, you might not even want to write that down necessarily, because you could plug and chug this. You see what I'm saying about the plug and chug? So yeah, just put a 0 here and you get 22, that's this part, and then put a 0 here and solve. So if oil pro is 0, then we get 22 equals a half equals 44. So you could plug and chug the answer too. Right.
It's just important knowing it.
Yes, it is important to know that for sure. And that just goes back to the same thing we've been doing with demand function versus inverse demand function. We need to keep it in its proper form if we're looking at slope-intercept form. All right, so how many will each of the firms, each firm produce in equilibrium? All right, you set them equal, right? So where the two lines cross seems to always be the hot point in economics. So I want you to think about it mathematically a little bit differently though. Because look at these two equations, the two reaction functions. Check this out. If I substitute this into this, because I know what the other guy's thinking, right? Well, he's thinking that I'm thinking if I do this, I'll do this. Well, we've got that, right? I know what he's thinking if I'm thinking this. So let me plug that in to this. And he's thinking the same thing I'm thinking, so he's going to take this, mine, and plug it into
How
his.
do you derive that in real life? I mean, how does that even?
This is more of an economic model, yeah. But that's
That'd be nearly impossible to like
well. Look at where we started from. Was we have a market demand function, and you know we know that there's just two players in the market, so. But yeah, we need to. This is economists doing some geeky crap again once in a while. But sometimes we start to gain some insights about how the real world might work, even from an abstracted model. That's what we're hanging our hat on. I'm not saying it works perfectly every time, but I think down the road it does. Blake, what?
So you're just plugging each reaction function
Into each other. Yep. And it becomes a little bit easier after you do it once. But go ahead and solve for O's reaction function, or you can do whatever one you want, but Okay, so here's the step where, let's see, if I'm being more careful, I'm subbing 9 into 8, for instance. So sub 9 into, you guys might have done it the other way, but sub 1 into the other, and solve for the optimal quantity. What'd you get for Oil Pro? 16 is correct. So I'm going to do one big step here, and then we'll, so QO equals 22 minus 1/2 of 20 minus 0.5 QO. That's kind of it in all its glory. We've got, you got to do a little bit of manipulation here, but you've only got one equation, one unknown, and at the end of the day, you should end up with 16 after you solve that out.
You
want me to do it?
Yeah, I'm sorry. Just maybe one more step out. Because you're going to want to
22 minus 1/2 of 20 is 10. 1/2, and plus, you got minus a minus inside here. So plus 1/2 times 1/2 is 0.25 or 1/4. But maybe I won't switch to fractions. Let's do 0.25 QO. Now we've got 1 QO over here, 0.25 QO over here. We can bring that to 0.75 QO equals 22 minus 10 equals 12. QO equals 16. So I said that it got a little bit easier now, because now we've got QO, let's call this equation, what are we up to here, 10? It's not really an equation, but this line 10, this result, we can sub that back into QG. We've got their reaction now. So sub 10 into 9 and solve for QG. And so QG star equals 20 minus 1/2 of 16 is 8. 20 minus 8 equals 12. And then if you want to get real fancy with mathematical, you put a couple slashes there and say, I'm done. Fine is what that means. It means put that in your pipe and smoke it. All right, so given the circumstances in this model, each company is going to produce these quantities ultimately. We've solved for equilibrium. This is what we'd expect to happen in the market. In reality, kind of like supply and demand, if the problems are different, then they're going to jockey around and like, oh, you produced 18 this month, I'm going to produce this, and maybe there'd be this type of play, but we've solved for what we believe where the market would be going. Okay, how much profit does each firm earn?
You could see
Price. Oh yeah, I did. Okay, yeah, we got to solve for price first. So part C, what is the price? So price, what do we need to do that? How much is in the market? What's the market quantity? 28, right? 12 plus 16, right? Oil Pro's doing 16 oil changes, and it's actually in thousands, by the way, but Grease Pro's doing 12. 16 plus 12 is 28. 2 times 28, 100. So to do that, we go back to the market demand curve of 100 minus 2 times big Q, which is 2 times 28 now. And that gives us 44. So each oil change is going to run $44.
Now where does that fit in our graph? Or when
It wouldn't. We don't have that graphed out here, yes. In order to do that, you'd draw a graph of this. Yeah. Or, if you've got your big girl pants on, we don't even graph it at all, and we just use the functions to put it in. All right, so $44. And now finally D then, what is the profits for each company? Each company is different, remember. So profits for Oil Pro, let's take first. So we get profit equals price times quantity. So we got 44 minus our marginal cost, which was 12 with these guys, yeah. Times the optimal quantity that they're producing, which was 16. And that number comes out to be 512, which is 512,000. Again, we want to convert this back to somewhat real world. Okay, 512,000. Grease Tech is also at a $44 market price. Their marginal cost was a little higher at 20. They're producing 12. Profits are 288,000.
So now, will the grease company see the difference in profit? Like, will they have any idea to know that?
Does the, and so yes, they might.
'Cause then it would make them change their process if their marginal cost was less. Would they do that?
Maybe, yeah. But now that's telling more to the story. So, do they have the opportunity, given the circumstances at hand, to make any changes whatsoever to make more money? No. So this is a Nash equilibrium. This is their best response to the situation. Okay. Now let's look at the result. Does it kind of make sense that Grease Tech is making less money than Oil Pro? Yeah, marginal cost is a lot lower. And does it also make sense that with the production quantities? Yeah, the company with the lower cost is producing more than what the lower cost company or the higher cost company was. So we get some results that kind of make sense by looking at these reaction functions.
The profit function that we're using on D is price minus marginal cost times quantity, correct?
Yes, and that's because there was no fixed cost. Marginal cost was constant, was another important part. Marginal cost is constant, just for simplicity. And so, in this situation, by the way, just so that you got this off the top of your head, because this does come up, if marginal cost is constant and there's no fixed cost, which is what it was assumed against a simplifying assumption, marginal cost equals average total cost equals average variable cost. They're all equal to each other. The functions just all collapse compared to the most general is our bowl-shaped look and something that looks like this. Marginal cost, average total cost, average variable cost. All of that collapses down and we kind of get rid of all the cost issues. Yeah?
So, going back to the actual wording of problems 8 and 9 are reaction curves.
8 and 9 are the reaction curves. Reaction curve, reaction function, yeah. The curve has got the kind of graphical connotation to it. Yeah. All right, good. Next time we'll look at, and let me just, I guess, kind of foreshadow, because it's related to this problem. We're going to allow Oil Pro to choose first, and then Grease Tech to choose second. It's called a Stackelberg model, because it's named after an economist, Stackelberg, that said, hey, what if one gets to move first and then the other goes second? How does that change?
So this is somebody's job in a firm to figure this out on a daily basis.
In probably not the way we're doing it, because this way is very classroom specific. In the real world, we have unknowns of cost, we have statistical variation and a number of different things.
You have more than 2 firms.
More than 2 firms, yep. So this is the thinking process of what if the situation is this.
I'm trying to say that translate in the real world to